forming. And I only went up to 9,000 feet, and we saw in the previous diagram it went up 25,000 plus. Off to the right, there's a number of data fields. There's the Cape, and this is a measure of how convective the air mass is in the area. And I can go to XC Skies and show you a little bit of that. You've got your K index, your lifted index, a whole slew of additional information that has been ascertained from the balloon and the models that they use to interpolate the data. So in this case it says lifted index of 0, which I think that was a not likely for thunderstorm development. So we may not get any storm development here. I'm guessing if we were looking at Ocala though, it was going to be probably a -6 because they were getting hammered up north. So that's additional information that you can research on your own and figure out how that can help you with your soaring information or your soaring assessment. I want to hold that here for just a second. Maybe I can go back to yesterday. Let me take a look here. See if I can get an archived data. There's this button here, load soundings. It shows all of the different models that you have available to you. So it's showing you can enter the lat and longitude, or there's a WMO ID, which I believe is an airport ID. So if you know your three-letter designated airport ID, you can just insert that in there besides the lat and long. It gives you the start date, and I'll see if I can go back. See if I can go back to yesterday. And then here in this drop-down box, it shows you all the different models that you can use to interpolate data on a Skew-T diagram. It's got RAP, it's got OP40, which is the default. It's got BOC40, which is a predictive, goes out like 48 hours. Got HRRR, which is now on XC Skies, GFS, NAM, and radio sound data at the very bottom. I usually use OP40 or BOC40, and when I predict the weather, I usually use the one that gives the best prediction. Try to be an optimist. And then I've gotten used to how Davis would respond when he was doing the weather back in the days. He taught me the most invaluable lesson. The weather's shitty, you called it to be good and it's shitty. The next morning you say, yep, the models had it wrong. It wasn't my interpretation at all, you know. Yes?
Word, Taylor, how did you pull that dial box out?
This box here?
Choose the sound.
Or the choose the sounding? Okay, I'll back out. So down at below the graph, the upper left corner says load soundings. And you just click on that. And then that brings up this whole box, choose the sounding. So we chose OP40. Oh, and I went back to yesterday. Let's see if it goes back. And I think that would be really cool to look at. So you can see it's loading.
For information interpreting these soundings, please see the following.
There you go. Yeah, there's a ton of data out there. There's some guys that have got some really good websites, if you Google search them, that make it even simpler and take you through some pretty nice steps to ascertain what's going on in the atmosphere. So this did go back to yesterday. We'll take a look at how about 4 o'clock. And now look at this. temperature sounding. So the red line on the right side, rising adiabatically, goes up to almost 5,000 feet. You got your dew point on the left in blue. Yesterday we had a temperature of 84 degrees. Looks like I'm not going to go out far enough, so let me grab this over again. So to get out of this, I hit the 150 millibar scale, and then I'm going to come over here at this is the hard part. 28 feet. It's going to be 85. I'm going to do the same thing. I'm going to grab this and expand it. This time it'll expand up to 11,000 feet.
Larry, that 28 feet, that's above ground level?
That is ground level, assumed ground level. So it's just a characteristic of the curve, and now that I've blown it up, you can see that I can pick the altitude that I want, 50 feet, 100 feet. So this was 4 o'clock. We were going to be at max temperature. Max temperature was 85. So if you look where my cursor is, on the right it says 54 feet. The top on the left it says 85 degrees Fahrenheit. It says 289 degrees, 8 knots, which is pretty, that's what we had for sure. Now I'm going to click on that temperature of 85 degrees. It shows the parcel rising on the magenta line, and when I plot, I won't do it, but you can see the lower left here, the dew point. It's going to follow the dew point line, the cooling line, and you can see that a cloud's going to form at that altitude, and that the parcel will not have reached equilibrium. So now you take the cursor. So here was the magenta line. I'm going to follow that up. Shows 12 knots at 4,000 feet. And there is where the clouds formed. In this case, it was saying 53. That was a little higher than what we were getting, though. I think we were getting, what, 48, Tim? Yeah. 46, somewhere in there. Oh yeah, I didn't get to 48. It was only 46. It was hard staying out of them clouds. So anyway, I mean, this is showing what we did basically. It's 13 knots now. It's kind of buried here, but on that last climb south of the sailplane port, you know, we were getting probably 600-700 feet per minute. Some guys were getting more. Beautiful climb, smooth, smooth, smooth Florida thermal. And then when we turned to tag and went downwind, I was seeing 14-mile-an-hour tailwind. So you know, it was a nice glide into goal.
Larry, could you do the same thing for 2 o'clock? Yes. Sure.
So, in fact, Janica, I want you to come here and do that.
No.
I'll show you how. So here, I'll take the cursor.
18 Zulu.
So 2 o'clock is 1800 Zulu,
yes.
minus 4 UTC offset. Here's the 2 o'clock profile. It's a little different. It doesn't look as sharp, does it?
No.
Now, I'll go back to 2 o'clock, but let's look at 1 o'clock. Yeah, it looks okay. And I'll just look real quick. 1 o'clock was probably about 77 degrees. Maybe 79. Top of the lift was 3,300 feet. So that's why we delayed launching until 2. Because we saw that the inversion, that is this part right here, the heating wasn't going to overcome that inversion until a little bit later. So now at 2 o'clock, let's say it was 80 degrees. 81.
Okay.
And at 2 o'clock we saw that the inversion had kind of gone away.
So inversions
is where that red line starts zigzagging back this way.
Okay.
And in this case, when compared to the 2 o'clock or the 1 o'clock, it's gone. It's now going straight up. So,
Question?
yeah, hold just 1 second, Willie. I'll get you right here. So if I take the cursor and I go up to where the condensation occurs, now it was saying 4,000 at 2 o'clock. And we weren't in the air at the time, so I don't know what it was at 2 o'clock. Anybody know what top of the lift was then?
We were saying 4,000.
Okay. So the other parameter is, here's the temperature at 4,000 feet. It's 59 degrees. So it's nice and balmy for Florida flying.
Okay.
You need 1 or 2 layers. And it's pretty decent. Willie.
Yes, Willie Van Fleur. Above the cloud line, the black line, there's some lines coming off the catabatic, the temperature, the catabatic temperature, is it?
He's talking about the
Adiabatic?
The horizontal red ones, what do they represent?
No, cloud condensation. Good question. So the spacing between the dry adiabat and now we reach condensation, so the cooling changes, right? Now it's a saturated adiabat, so it curves like this. I'll expand out so you can see it.